Welcome in the International Railway Summit. This session will deal with the topic related to infrastructure, that means FRMCS, Future Railway Mobility Mobile Communication Systems, designed by UIC as the successor of GSMR and also as an enhancer of rail traffic safety. My colleague here, Dan Mandock, head of FMCS at UIC, will moderate this session. Dan has worked for Romanian Railways as head of the Telecom Digital Management Center, head of the network. Then he worked for the UIC when he coordinated the GSMR interference activities, the ETCS over GPS project, and launched the FRMCS activities as the UIC project. Then he was the ERIG chairman. Then Dan worked for Network Rail as professional head telecoms. Starting in 2019, he returned to UIC as head of FRMCS and cybersecurity solutions project manager. Dan is graduated by the Transylvania University from Brasov in Romania. So Dan, you have the floor now. Dan, I cannot hear you.
Thank you. Apologies. Thank you very much, Mark. Good afternoon, ladies and gentlemen. We're going to try to give you an insight of the telecom. I'm going to speak about the future of telecom when discussing about the future railway mobile communication system. We will say this in our slides, as Mark very well explained. Today, railways are using a system called GSMR, which is a GSM for railways, a 2G system, which provides interoperability and which provides safety through the emergency call and supports ETCS. Being a 2G system is going to become obsolete, and now we're working to put in place the FRMCS, the Future Railway Mobile Communication System, which is a 5G system and successor of the GSMR. It will sort out an issue of obsolescence and a risk for railways, because if there's no radio layer, then there's an issue with the signaling part and safety, and also will enable digitalization. We will have, I have the honor to have two colleagues here. First of all, Patrick Marsh. Patrick Marsh is within the digital rail organization of DBNets. Leading the platform development activities, which comprise the specification, development, standardization, and prototyping of the connectivity, computation, diagnostics, and IT and OT security platforms needed for future rail operations. Patrick holds a PhD in wireless communications. Patrick will have a presentation and present the activities and the planning in Deutsche Bahn and the Deutsche Bahn position on it. Then also we have the honor to have with us Michael Clocker, who is the head of solution management railway at Nokia, and is responsible for positioning of the GSMR solution, however, as well of the future railway communication system, FRMCS. In this role, Michael interacts with customers, analyzes the market needs, and represents Nokia in various standardization, legislation, and industry forums. Michael holds a master's degree in computer science and is currently based in Munich, Germany. So with this being said, we will have two presentations, one from me explaining the projects in FRMCS and the planning, and one from Patrick explaining the Deutsche Bahn view on the planning and digitalization. After that, we'll organize a question and answer session. Don't hesitate to start sending your questions while we hold the presentation. If you could put in my slides, Jenny. Thank you very much. So just a second to start my timer to be in time. Today, as we said, today the railways currently use the GSMR system for operational communication, which is a key component of the European Railway Traffic Management System, ERTMS, which is part of the TSI, of the Control Command Signaling TSI. It was designed 20 years ago by UIC and is completely border crossing interoperable, deployed on more than 130,000 kilometers of track in Europe, and more than 210 kilometers of track worldwide. It is supporting the train driver to similar voice applications, including the Rail Mercy Call, which is considered to be the best method to avoid a train accident when all the other system has failed, but also the ETCS, which is the European Train Control System. Even if it's a limited data capability, GSMR is supporting also railway application like trackside telephones, passenger information screens on platforms, and other. So it's already a usage which is outside the control command signaling, but helpful for the railway system. The Future Radio Mobile Communication System, FRMCS, is the UIC response for two elements of strategic importance in the future of the railway. And this is very important, a very important message. It is something that has to come because GSMR is a 2G system and it's coming end of life. The manufacturer announced the GSMR equipment is due to reach the end of life around 2030, and it will be supported until around 2035, subject to support from the railways and from the customers. However, without a suitable and timely replacement, this will heavily impact the train system in Europe because there will be no traffic without GSMR, because you need to have a emergency call to keep the safety, and you need to support the ETCS. But FRMCS is not only apologies my language, a fancy replacement of GSMR. It is a complex issue, indeed. A specific railway requirement as functionality, emergency call. Not every system can do it. Quality of service, life cycle, cross-border interoperability, and European migration timeline. But it's also a significant opportunity, which is to enable and support the railway digitalization, the need to transmit, receive, and use increasing volume of data, which is at the very heart of sustainable transport. We need to having this improving of telecom service quality, potential offered by Internet of Things, smart maintenance, wireless connectivity instead of line copper or fiber cables, or driverless train. Railways need a suitable radio system to enable this ever-increasing communication flows in an efficient way. I would like to speak a bit about the FRMCS projects. Basically, we have two projects in UIC. One is called the Future Railway Mobile Communication Project, which is a project which has as a scope to provide the overall technical condition for the successor of GSMR. Basically, through this project, we want to develop the technical specification and related study, strongly connected to ETSI, representing the members is FGPP, and in full transparency to the ERA and the stakeholders, UNISIG, Unitel, CRIM, or Shift2Rail. We started with three main directions to provide the baseline platform, which is the user requirement, system architecture, and frequency system. And we are now delivering through this a replacement to IRINI function requirement specification and a replacement to the IRINI system requirement specification. We also have to start working on the transition, and therefore we launched the FRMCS migration scenarios. We're working on four directions. First of all, if you take on top left to ensure the scenarios for migration for the onboard, how do you do with ETCS having to work in parallel with GSMR and FRMCS, and to develop the onboard functional and system requirement specification. Then to think about the NE network migration and scenarios, where the NE network is the connectivity between all the GSMR operators in Europe, which are not going to peer-to-peer, but in two hubs, one in Germany and one in Switzerland. Then about the signaling operation continuity, which is giving all the information needed to our colleagues in ETCS to develop ETCS over FRMCS. There's right now a very strong discussion about this with decisions happening in parallel at the moment that we speak. And finally, to think about migration spectrum needs. A flavor of FRMCS specificities. All the specifications that we do are based on the user requirement specification. The user requirement specification was written by railway people, which wrote it in the language of railway users, when you press this button, this is what's going to happen, which was then, of course, reviewed by our partner suppliers to make sure that this is more or less possible. And then it was shared all around the globe. We had more than 1,000 comments to this. You can go to this link and download, and we accept any new use case from anyone. Try to write it in a simple, accessible language, and it's the basis foundation for any specification that we do to keep them consistent. Then I wanted to give you a flavor on how do we do this system. We are basically having a 5G system, and from the user requirements, we transfer the users in 5G specific organized 3GPP language, check it in ETSI Telecom Committee for Telecom, and apply them through 5G, the 5G workstream. Basically, our requirements will be in the 5G third edition. We are modifying the 5G for the needs of the railways. As said before, the FRMCS first edition that is planned to be available for implemented the second half of 2025 will be a 5G system based on 3GPP Release 17, or to say it in a more easier way, the 5G third edition with equipment available in the last part of 2023. This embedded timeline here is coming from CGP website and is showing the moment where the standardization will be finalized, from where we can count 2 years, 1.5 to 2 years to have the product. And it's very important to say that we are basing our needs on user requirements. These user requirements were selected by the railways to be the basis, the operational expectation for the system that will be there in 2025. So it's going to be based, as we said from the beginning, on the user requirement. User means railways. As planning, we always had the goal and to have a first edition of FRMCS available for railway to start national trials in the second half in Q2, Q3 2025. It will base on as I said before, on 5G third edition. It's going to have mission critical service products support, and we're going to have them tested. We have a 3-step approach, as you can see. A first step to build the first specifications and to prepare top 10 frequencies, which now they are obtained almost. We have the last step to reach, and to prepare signaling transition. Then to test it, and I'll have a few words in a short time that I have on the project called 5G Rail, supported by Horizon 2020. To have new specifications which are a result of the outcomes of the testing, of the prototyping, and then to keep working on developing the elements for the transition. In the same time, to have the support from the Commission and from ERA, to have a TSI legalization in 2022 of FRMCS, to have a clear indication for railways that in 2025 this will be the system that they have to use. And therefore, for the first implementer to be able to start the procurement process, which we know for railway is not easy. And then in the last part, to be able to do European trials, which will allow to have stabilized specifications and together all the other elements that we have with a TSI inclusion through a method or another to be able to have the system in 2025 for railways. Very few words about 5G Rail. 5G Rail is a European project which is supported via DG Connect, Horizon 2020. It is a project that allows us to build test cases, build a prototype, then test the prototype in lab test in 2 test labs, one in Hungary and one in France, from 2 major suppliers or from Telecom, and then to have them test it in the field in France and in Germany, and then based on the results to be able to do a more solid version of the specification, because we have this B cycle where we have the initial requirements, the first specification, the product, and the product testing. We also have a part where we're going to look on the possible synergies between railways and roads. When you have one network that have a track and a road, how can you have some more synergies? And then to have a validation of the test and input to the CCS TSI. And I have a last slide where you can see the 8 work packages, which is a test definition, test result, and consolidation, onboard prototype developments, validation of ETCS, voice, TCMS, and video with laboratory tests in 2 different laboratories, field implementation and evaluation, render road communication system coexistence, dissemination communication, and project management. And here you can see the 18 partners of this project, where we have important railways, important suppliers, and 2 universities. This ends my presentation. Thank you very much for your kind attention. If I could hand over to Patrick. Thank you.
Okay, thanks a lot, first of all, to Mark and Dan for the invitation to take part in this session here and the chance to actually present some slides. I hope you can hear me well. Is that the case? Okay, and thanks also for showing the slides here. Okay, so as mentioned, or as Dan introduced me, I'm Patrick Marsh. I'm in the Digital Rail organization in DB Netz, so in the infrastructure manager part of Deutsche Bahn, and I'm responsible for the platform development in this organization, which comprises the connectivity, computation, IT/OT security, and diagnostics platforms we need for future rail operation. And I would like to use this chance of this short presentation to show DB's view on FRMCS, in particular providing some background on what we in general envision regarding future rail operation and why it is so important for us to introduce FRMCS in the right way and especially in a very timely fashion. So starting with the broader vision of Deutsche Bahn, we actually belong to a sector program called Digitale Schiene Deutschland, or Digital Track Germany, if you translate this. And this is purposely a sector program, not only comprising Deutsche Bahn, but also all the other railway players, all the railway undertakings which are in the market in Germany, as we want to bring the overall sector forwards. And in particular, we have the vision to substantially increase capacity, quality, so in terms of punctuality, and efficiency in terms of cost and energy efficiency of future rail operation. What we envision as the target way of doing rail operation is that we have an AI-based traffic management system, which for the whole country of Germany can in real time dispatch and redispatch rail operations in such a way that if you have certain effects in certain areas like weather conditions or certain interruptions, that the system can basically in real time replan the traffic and minimize delays. In a similar way, we also envision to have crowd management, so also a real-time AI-based management of passenger flows to also minimize the times that people actually need to change trains. We in general envision that we have trains running automatically. Explicitly, we are here looking towards GOA4 operation, meaning fully driverless rail operation. That may not be applied in each and every case, but this is the target which we have in mind when we, for instance, also design the FRMCS system. And then we envision that we have trains driving at optimal headway in the form of EDCS level 3 moving block approach. And in the context of automatic train operation, of course, we need mechanisms to be able to detect obstacles and react automatically in the case where there is no rail operation personnel on board.
Patrick, please. Could you switch on your camera, please?
Went off. Okay. Last but not least, we also envision to have a fully automated incidence prediction and management, again, to minimize any failures in the rail system and, again, maximize capacity. To achieve all this, we have to introduce quite a lot of technologies into the rail system. In particular, as you can imagine, if we're talking about driverless train operation, this means we have to introduce sensors like LiDAR, radar sensors on the trains, which can automatically detect hazards. Also, high precision localization is vital for this very dense driving, which we have in mind. Here in particular, we're working on solutions that would combine different sources of localization, like inertial sensors with GNSS-based localization and the detection of landmarks at the trackside for very precise localization. I already mentioned that we plan to introduce artificial intelligence, for instance, for the capacity and traffic management. So it's quite a lot of technologies which we are introducing, where we are purposely recruiting persons from other sectors to leverage the advances from, for instance, the automotive sector or other sectors, and bring these in the rail sector. Obviously, the basis of all these technologies is that we have the right connectivity and also computation fundament. So in this sense, obviously, the FRMCS system is a vital backbone of our vision of future rail operation for two big reasons. On one hand, obviously, the current GSM-R system will become obsolete quite shortly, so we anyway need a replacement. And also we see that the requirements of future rail operation are way beyond what the GSM-R system could support. You see here on this slide from left to right some example use cases which will become relevant, and they kind of from left to right have increasing requirements. It's here important to stress that even if we are not yet talking about GOA4 operation, so fully automated driving, so if we are just talking about high density driving in minimal distance, even then already we see a need for communication between train and infrastructure that would bring GSM-R to its limits. For instance, because we have to exchange digital map data, which has to get to the train. We have to send movement authorities up to every second and so on to get into this really maximum capacity mode. And if we then look further to the right towards the GOA4 operation, and we're talking about exchanging sensor data from train to track side, or doing things like remote train control, so to take control of the train in an incidence case if there is no personnel on board which can do so, then of course we are suddenly talking about massively increased connectivity requirements. On the bottom of the slide, you see as a kind of rough ballpark figure, we're here talking about an increase from nowadays 30 kilobit per second per train on average to something like 3.5 megabit per second per train. And the latency requirements also get 2 orders of magnitude more stringent and clearly get beyond what a GSM-R system could actually provide. Because we see it so important to introduce FRMCS, Deutsche Bahn, or in particular DB Netz, is very active. We are, on one hand, very active in standardization, for instance, in UIC, but also in ETSI, EUG, Shift to Rail, and other groups. Also, for instance, leading the spectrum activities in UIC, and we have in the past led the FRMCS architecture work in ETSI. And are now moving forward on the normative work there. We think beyond standardization and regulation, it's important to go into R&D collaborations bilaterally with industry partners, and we have had a lot of collaborations or are having collaborations, for instance, going into antenna systems, end-to-end design, building a resilient overall FRMCS infrastructure, etc., or looking into hybrid FRMCS infrastructures, so which are partially railway owned, partially making use of public networks, because we see it's important to see how we can tweak the off-the-shelf solutions which the telecom vendors have specifically for our rail needs. And then on the right side, you see we are also very active in technology evaluation and pilots. We have one pilot running this year, actually, alongside the ITS World Congress, where we demonstrate 5G in the context of a GOA4 fully automated shunting. And we are establishing a big test ground in the Erzgebirge, an area in the east of Germany. There we have just now selected partners to do first measurement campaigns for innovative antenna systems, which will start in spring. And we have an ongoing tender to select partners for a first end-to-end connectivity setup, which we expect to start later this year. And as Dan has already mentioned, we are also a partner of the 5G Rail project, where we will also use our test field Erzgebirge as part of that validation project for FRMCS. Coming to our timeline shortly, I would, for this slide, basically start on the end. So at the bottom, you see these gray items, which are key final milestones for us. You see here we envision, for instance, to have a GOA2 rail operation based on a DB-owned FRMCS system around about 2027. We also envision to have a GOA4 based rail operation around about 2030. These are very milestones for us, because this in consequence means that we need to have FRMCS standardized early to have everything in place to actually start rail operation based on FRMCS in those times. In fact, as you see on the bottom left, we also envision to have GOA2 rail operation involving ATO, so automatic train operation, already in 2026. But because we won't have a fully specified FRMCS system in time for that, we will here resort to a public 4G, 5G network and not yet a full FRMCS system. But that's basically only a temporary solution until we then have an FRMCS system specified and available on the market. So that's the reason why it's so essential for us to have, for instance, the first ERA TSI 2022 next year already capturing a good first FRMCS version, which also includes explicitly ATO GOA2 support. And then you see here on the left of the slide, basically all the other steps we're taking. So different evaluation activities are already mentioned, our measurements in the Erzgebirge, etc., the activities in the 5G rail project. We do hope that beyond 5G rail, there would also be other FRMCS evaluation projects, ideally cross-border evaluations, possibly funded in the CEF2 context that we have to see. But it's obviously very important that we have a lot of trials and mature technology before we then start rail operation based on this. As a final note on this slide, I would add here that we in general assume we have a Deutsche Bahn-owned active FRMCS and 5G infrastructure. We may consider using public networks as a fallback, but we envision a large extent of passive infrastructure sharing between Deutsche Bahn and public operators, because that's where 90% of the cost is. And we see a lot of benefits if we, for instance, jointly deploy masts with public operators to share costs, basically. Overall, we envision to have the overall transition from GSM-R to FRMCS done until 2035. And then I would conclude with one slide which lists our most urgent needs. The first one I've already mentioned. So because we have such a stringent timeline to introduce a new form of rail operation which requires FRMCS, it's critical for us that in the TSI 22 we have an FRMCS version 1. It doesn't have to be mandatory, but it's sufficient if it's optional. But it has to be in a form that we can refer to this in tenders for onboard and trackside equipment. And it explicitly also has to include ATO GOA2, which is currently a point of controversy in the standardization bodies. As it seems critical, at least from the perspective of some players, to cover ATO in the TSI 22, we would like to seek opportunities to compensate for that in other ways, so to have the needed specifications ready. For us, it's also very important, if it is not possible to cover everything in the TSI 22, we would need to see if there are ways to have amendments to the TSI in the years shortly afterwards, for instance, in the form of technical opinions or so, because for us it would not be possible to wait until the next TSI in 27 or so. That would be far too late for our plans in Deutsche Bahn. And with that, I'm done with my presentation, and I would like to thank you for your attention.
Thank you very much, Patrick. Thank you very much for your presentation. I hope those two presentations gave a flavor on what railways are preparing. And as we both said, or the three of us said, also Mark, also Patrick and myself, we said that actually we have to do this change of GSM-R, which is becoming obsolete. However, this is not only a change, this is a very big chance. In the same time, maybe we find time in the next Q&A now. It's important that we move very fast, because the time, for railways, 10 years, if we think 2030 or 2035, the time is very short. So we will open now the Q&A session. Please don't be shy to ask questions. We are open to discuss any questions. And I'm happy to see a first question that was addressed. And the question comes from, I think it's I don't see from who. The question is, what are the benefits of introducing F1MCS? I would address this question to you first, Michael, but then also I will address it also to you, if I'm allowed, Patrick, to have both a supplier and a railway view, a user view.
Thanks, Dan. I think for us as Nokia, as we are, active for sure in the public market, where we are addressing 5G technology currently with a huge benefit for the public operator, but also and especially for vertical industries. I would say that this is one of the main drivers that we see on the one hand to fulfill the needs that we saw before in the presentation, introducing digitalization and automation for train, simply become more competitive when it comes to freight trains with respect to let's say other transport like tracked transport, on-road transport, and for this we want to build the capabilities, and FMCS will mainly rely on 5G, benefiting from the different functionality which is addressing different vertical segments. On the other hand, we as Nokia, we are one of the leading and first deployments for GSM-R. At this time, we did this as under Siemens in 2000. I think the first network in GSM-R was established in 2000, after also some trialing phase. And as industry, we have said, have a look on the market. We are benefiting a lot of public technology with GSM already, and we will do with FMCS. But we have said early, several years ago, that there is a risk that at some point of time, the GSM technology, which is based on, let's say, TDM technology, will be very challenging to maintain in the long term. And this is not because technology is in theory leaving the market or leaving the capabilities to support it from theory point of view. But what we see is the limitations we see on mobiles, on chipsets. Technology like TDM is not used broad in public markets. If you want to hire new people and you ask them, please do a tiny comparison of radio technology, GSM and 5G, and then you will get the answer, oh, I'm not very experienced in TDM. So we have limitations for a very long support based on chipsets, based on technology, but also in the future, I guess there will be a challenge for everyone in the sector, whether this is the operator or the vendor, also on to gain the know-how level. And but the main driver, especially when it comes to mobiles and deployed radio technology, is the capability to maintain chipsets, modules in the core network. At least what we see, it's much easier because already in GSM-R we are introducing, let's say, modern IT technology which allows for a smooth migration. But other areas are challenging, and this is why we have industry have said, okay, 2030 with specific extensions we know already is a good value to have a guideline also here to push for the introduction of FMCS. But as said, obsolescence is only one topic, and for us, and this is, I guess, what we will see in the market. The main driver should come from the capabilities of FMCS to introduce digitalization and automation.
Thank you very much, Patrick.
Yeah, I think I already mentioned two main points in my slides. Yes, on one hand, GSM-R will become obsolete, so there's no other way than introducing something new. And you've seen the requirements of future operation require a new generation of telecommunications. But I would also add to this, I mean, we also see a lot of further benefits of the FRMCS system. First of all, the fact that we introduce a clear separation of applications from telecommunications technology, which we don't have nowadays, like with things like Euro-radio, where you have a bad kind of intermingling of application-related functionality and connectivity. So to have a clear separation and to allow for different life cycles of the application and telecommunication is one big paradigm change, I would say, in FRMCS. And then the fact that, of course, with the 5G and also the MC technology, we would be able to have solutions which are natively cloud ready, which allow a very different form of deployment and orchestration than a GSMR system. That also moves us into a novel era, yeah, of technology. Yeah.
Thank you. If I may add a few practical, my view, a few practical things, which is truck side. There's a lot of applications. If you take line side phones, some people will say they are used just for maintenance people, but actually, in a number of cases, limited. They were the distance. They were that asset that make the difference. So there was no accidents with victims. I know in my experience in railways, a limited number of cases, 3 or 4, without which we would have a frontal accident with casualties. Now, this is a very expensive phone. It's just a phone, but you need a cable to make it work and connect it. Think about this phone becomes wireless and independent. Cameras on level crossings, cameras on bridges to check the integrity when you have a doubt, intelligent infrastructure for land sleep or whatever. And I can tell you about these applications for a long time. All those things will now be possible in a wireless mode, in a future-proof way, because basically we took a decision together with our colleague from industry that we go for a commercial of the shelf as possible system, but in a future-proof system, because any system coming after 5G third edition will be compatible with what we are doing now. We have different life cycles to mobile network operators, but still we would have a system that we know is developed because of the industry. So I think there are benefits of it. And I also want to say about the risk. In a certain country, on a certain incident, it doesn't matter where, there was an outage of GSMR for a number of hours. Half of the train driver refused to start the journey because they said, there's no emergency call, I'm not starting this journey. So this is saying a lot about the need for this railway layer, which even if everybody says, telecom is no safety. There's no safety in telecom, safety is in the application, but it's still needed to be able to do the traffic. So on one side, as you said, both of you, Patrick and Michael, it's the need to solve the obsolescence. But on the other side, I think that we have this possibility to bring new applications and to take the railways to the next level. I see a question from Jules. What is the likelihood of take-up outside of Europe? I think this is for you, Michael.
Yeah, I think this is a good question, because with GSMR, which was, let's say, mainly driven out of Europe, we have been challenges in specific countries simply to deploy the system, even if this was seen as very useful. The good thing is with GSMR, we were already available because of the technology deployment that are available in the spectrums that are available. So we had we were able to deliver GSMR already in China, in Australia, in India, in several states in Africa, but other countries like North America or South America, or some countries where this GSMR spectrum was not available, it was not possible. Now with FRMCS, where we want to rely on the 5G technology, we have now much broader possibilities on the one hand because of, let's say, spectrum support. We have spectrum in in the various forms. So in Europe, it's clear we will have a definition of a dedicated railway spectrum in 900 GSM-R band and 1900 band. But in other countries, we are now very flexible to also deploy FMCS in that area. So this is for us as industry and also for the benefit of the railway sector now a much broader possibility and market worldwide, because this is what the user requirement specification also starts probably from Europe a point of view as let's say the most driver here, but it's getting an international project, and I think now in USC but also in 3GPP we have also a lot of contributions, for example from Japan, from Korea, from other countries to help to make this FMCS a true global solution, which is of the benefit of everyone. And this is also additional topic. It's probably not directly related to FMCS. Is the benefit with other segments? As I've said already, the 5G technology and the and also this mission critical environment. This is not only what is needed for railways. We see this also in other areas, and especially these public safety domain was one of the first trying to solve the obsolescence they had with Tetra. So they also introduced this already with LTE technology, and a lot of these mission critical functionality that were invented by them we will base on. And so this is the second I would say synergy topic where we can even benefit also from other segments. So we have synergies within railway, and I've even not discussed that we are also addressing with FMCS specific metro and urban railway, so not only mainline. And then we have the synergies due to the 5G technology worldwide, and we have the synergies on the mission critical functionality with other critical segments like public safety, like energy and others. So for us, I think this is the much better solution compared to GSM-R now with respect to possibility to deploy the system and the basic communication principles, the mission critical communication worldwide in various segments.
Thank you very much, Michael. Would you have something to say to this question, Patrick, or?
Yeah, I can just stress it's of course for us vital that we have a system which is maximally based on off-the-shelf and mainstream technology. You cannot avoid that you have some railway specialties. I mean, we are asking for solutions for certain spectrum which is unique to railways and so on. Yeah, so there have to be some little rail-specific components, but otherwise we would hope to use off-the-shelf 5G and off-the-shelf mission-critical functionality. Mm-hmm. One issue we do see in this respect, I mean, you've touched this, Michael, the mission-critical framework is also used by other sectors, but we see that the 5G extensions of this are currently mainly driven by the railways because there are not too many other sectors currently active in that field. So we would hope that also other sectors get active again. So we have not, again, a rail-driven technology somehow there, yeah?
Yeah, if I can answer, yes. One of the reasons is that one of the first drivers of these mission critical communication in 3GPP with the MCX framework was coming from the Tetra, as I've said, and they are starting a couple of years ago already. And at this time, they focused on LTE. And this was one of the main reasons why currently most of the deployments we are also doing in mission critical sector is simply LTE, because this is a proven mature technology which is available. When we are coming to railways, where we are still have 5 years ahead, I think we have a common understanding that at this time, because now 5G will get broadly deployed, not only in the public market, but also for other verticals in the upcoming years, we have said that this would be then the right technology to start for German railway. And I guess for railways, sorry. And I guess this is the same then also for other segments. So the first interest will come naturally also from other areas to go for 5G.
Thank you. I would address a question personally, if I could, and I'll address it first to you, Patrick, and then to you, Michael. I have my own view also, but I think the most important view is coming from you. And the question is, I'll look into your slides, Patrick, and there was this emphasis that personally I support 100%, because if you want, I can say 150%, but I supported 100% on the need to have the FRMCS recognized, or I would use a bad English saying legalized in 2022. It's up to her and the Commission to find the right tool. But I think it's important for railways to have this. I think it's worse that we, when you do this 10 minutes presentation, we give a flavor of important aspect, but I really think that it was to discuss a few minutes on this critical aspect, which is one of the aspects of the day. Could I have a more in-depth set of a view from you as Deutsche Bahn leader? Why do we need this legalization of FRMCS in 2022, and what does it mean if we skip that, actually?
Well, as you've seen from my slides, we have concrete plans to introduce forms of rail operation, including ATO, GO-A2, around about 26, 27, and we would like that to be based on FRMCS already. Yeah? And then if you count backwards, I mean, you have to consider some time for technology development. We understand certain vendors will only finalize their plans when there is a specification ready, obviously. You need plans for time for tendering and so on. Yeah, so you have to plan some buffer, and then this quite easily leads to the fact that in 2022 or shortly afterwards, we need some essence which we can refer to in tenders. Yeah, it's important to stress for us that things don't strictly have to be finished end of 22. Now, obviously, ERA has certain granularity of TSIs which cannot be changed so easily. So if there are options to say, okay, we have a, let's say, limited specification in 22, but it's then finalized in 23 through some suitable amendments or technical recommendations or some similar format, that could also be okay. But we cannot afford to wait until a couple of years later. That would destroy our DB plans. Yeah. And then regarding the ATO topic, for us, it's always a bit difficult to understand why we say EDCS over FRMCS can be included in the TSI 22, but ATO over FRMCS is tricky, because we would think it's more or less the same or easier. It will use the same, purposely the same architecture, the same interfaces. So it is not fully understandable where the difference is. And rail operation without ATO is not, reasonable anymore in a couple of years.
Thank you. Do you have what is your view on this 2022 legalization discussion, Michael?
Yeah, from our side, this is especially for the Europe market, because this is clear. This is the TSI. For us, it's absolute mandatory to have the legal framework in a way that it allows for our time plan that we have to start with the introduction of FRMCS in 2025. So this is an absolute must, because any delay we would now have in the legislation, and even if 22 is the first focusing on the onboard architecture, is so important for the overall timeline. Yeah, because if you consider an onboard renewal, you will not do this every year. It will take several years. And if you miss this window by having a late availability of the legislation framework, then you miss the market by several years. And we know that we will have projects which are currently still deploying, but from some kind of time we want to deploy the new technology. Otherwise, we will have situations where we have GSMR to be rolled out at a time when we are only going into, let's say, into support mode. But we cannot deploy GSMR networks in 2033 and then say 2035 we have to stop. It makes no sense. We will have projects which are probably already now considering, shall I invest in GSMR or shall I wait one more year for FRMCS? But they cannot wait too long. They have their plans. And this is for us important as industry, so that we will be able in 2025 to start with the deployment and also to manage projects where we have to migrate. So for new projects, greenfield projects is probably easier to do, but for the networks where we have huge installed GSMR base, we need to start the migration. This is also nothing which you do overnight. It will take several years. And this is why it's so important to have the legal framework, because otherwise I fear that the investment of the railway operator is not there, because if there's nothing specified, it's hard, and investment cycles, Patrick mentioned this, are could be quite long in railways. Yeah, so it's also nothing that you can release every year. So this is the overall view, I guess, also supported by the industry, that we need to have this framework to trigger the deployments which are needed.
Thank you very much. I think it's difficult to say more things. I'll try to say still a few things, because this is such an important subject. And basically, if you look to the top profile of this summit, I think is one of the subjects that should be understood and discussed by the political dissidents of this summit. Just to start with I'll call it a detail. I hope I'm not offending Patrick. I agree with you. If ETCS is possible, then ATO should be possible. We just agreed in a way that it should be the same telecom architecture and the same interface. And I agree with you that we should discuss it with the same power. I personally, I do work for UIC, but I'm coming from railway networks, and I'll go back to railway in a day, sometime in the future, God knows when. I cannot imagine a railway without an ATO system. We cannot afford to have more trucks. We need to put more trains on the same track in a safe way, in a performant way, because there are more people using the train. There's more freight using the train. This year is the year of the railway from the Commission perspective, and then without ATO, it's like you're having a car without no intelligence on the highway. There's no functionality and no feature to help you ride normally and safe on the highway. So I fully support your view on the ATO from my perspective. Now, to come back, I think there are a few things to be said that were said, so it's better even if I repeat a few, just to say a few things. First of all, we have an obsolescence management problem in Europe, because basically we are 27 states, some 24, 25 of us have railways. I hope I'm not saying a stupid figure. I mean a wrong figure. And the migration will be very diverse. Each country will migrate when the business case for them is right. Then you have countries which want to have innovation, digitalization, etc., and they can do this, and they have a GSMR network SIM sometime. Then you have countries with a very young GSMR network thinking about what are we going to do. It's going to be a very diverse and very complex migration. However, in my view, as head of FRMCS in UIC and working on this planning, this planning was very carefully chosen. We did the fastest option possible, so we have the maximum of use cases in 3GPP. We have time to receive the frequencies, and we will have them in time. We have time to understand more about the products, so they come in time. We can do our trials and have the product. It was the shortest time possible. It cannot have shorter. You can have much longer. But in my view, if you take 2025, if we have a big gap from 2025 with more than a few months, then we have a real migration problem, because as you said, Michael, and I think that you agree with me, Patrick, how will you have all those European networks migrating until GSMR will really before the GSMR will really not be supported anymore? Because there's an element that people should know, is that the GSM licenses are almost finished in Europe. And therefore, the GSM case in Europe is almost finalized, and therefore the GSMR product is becoming a problem. So then, to be able to have to start implementing this system in railways, the procurement process is very long. The 2022 mention of the FRMCS with the planning for 2025 allows railways to plan the procurement, even if a national trial or even more than that. Railway cannot buy like the MNOs in 6 months. It's years. This is public money. It's years. It has to be scheduled and all these things. I really support Deutsche Bahn in this, and we have also written to in our planning document MG7905 for documents for the TSI 2022. We really ask for consideration of. We are calling it in this way, legalization of FRMCS in 2022. it doesn't mean it's going to be in the TSI because not a proven set of specification. But they will be good enough in 2022. They will be already tested through 5G rail, and we already know that they will be almost mature. So railway can start the procurement process. So from my perspective, I'm supporting this statement from Deutsche Bahn 100% because I cannot say more than 100. But if there's a maximum figure, I would say the maximum figure, which is above 100%. Thank you very much for this. I would ask another question. Are there any new questions in the Q&A? Because I saw a line here. If not yet, I would like to ask. I would like to ask you, Michael. How do you see the benefits integrating the Internet of Things within FRMCS? Because this was a big discussion. You, as from your point of view, because you are building these kind of things in Nokia, how do you see this integration, the benefits, and if there's any challenges to such integration?
Yeah, I think this is, as I've said, when we are addressing FRMCS and we are thinking about 5G, then it's implicitly available because, as I've said, 5G is not only the next better smartphone broadband capabilities and capacity and bit rate, but it's really explicitly addressing vertical segments, but also machine type communication. And there are measures within 5G which allows to have millions of devices to manage and to allow for devices with batteries lasting for 10 years. So there are mechanisms within, for example, the signaling or within the administration which allows to handle a lot of sensors. So this is the good thing. We are getting this technology we have. And now how to integrate them with FRMCS. This is exactly the benefit that we see. We have the system as a one integrated system. If you want to make some applications, build some applications, for example, an automatic warning of people or trains in an area where a sensor which is observing the track, whether this is flooded by water or other things, we can combine these logic using automation by triggering, for example, the emergency alert functionality that we will have from the MCX world. Or we will put sensors like cameras or movement sensors at level crossings, and then we are adding with some local edge computing, which we are also get from the 5G technology to do some local, let's say, artificial intelligence to detect by software if there is any movement, and then we can automatically also inform the train which is arriving. So there are a lot of use cases, and if you put them completely separate, like doing IoTs, and let's do voice communication, train communication, train control, TCMS. I think there's a lot that you can combine and automate. And this is the problem, the problem that we would have with completely separate networks. With FRMCS and 5G, we can have one network with the capability to integrate those things and then benefit from further automation, artificial intelligence. Patrick mentioned already, this is exactly what allows then to combine with your decisions that you are taking, with the triggering that you're taking. You do not need to notify only a controller, but you can immediately automate and inform trains or put some signals towards the workers in that area or whatever. So this is, I think, the clear benefit.
Thank you very much. Taking account that it's only 2 minutes, I would like to make a one minute conclusion and then hand over to Mark for the final conclusions.
I have to leave now. I'm sorry, I have to leave for the last panel. I will let you finalize that. And for that, it was very exciting with an amazing project and planning to replace GSMR and functional with functional and technical evolutions. Yes, it's a real challenge. Thank you, Dan, Patrick, and Michael. You can continue in this.
Thank you very much.
Bye.
Then let's do it in the following way. So, would you have the challenge for 40 seconds to have a message from you, Patrick, and from you, Michael, and then I will do a close up for the remaining 40 seconds. What would be your message on FRMCS, Patrick, to the audience? A 40 seconds message. Well, it's a challenge. If you don't like it, I'm sorry. Apologies.
We have very ambitious plans in Deutsche Bahn or in the Digitale Schiene Deutschland sector program. For that, we need FRMCS, and it's very important that FRMCS is introduced in the right way, so including ATO support in a very timely fashion. That's my 40 seconds summary.
I don't think you can have a better one. I think this is great. Michael, a 20-30 second message?
Yeah, and I think that it's important that also we as vendor can support railways. I think this is the clear understanding and the capability of our system to support such digital automation and digitalization of railway, because this is for me the main driver of introducing FRMCS. And if we are making this in the best way and have all the capabilities, you will start deploying it. This is naturally because there's a benefit for railway operators. And then at the end, it's a benefit for the network suppliers as we.
Thank you very much, Michael. So I think that we are at the end of our time. Thank you for the effort, and thank you for the presentation and the good discussion. We try to give you a flavor of what's happening in the future of telecommunications for railways. And mark my words, this will not be just a fancy new system. This will be, I wouldn't say a revolution, but quite a change to railways, because we will have now 5G in the railways, and we'll have a lot of opportunities to make better railways via this system. Thank you very much for all for joining this lot, and I think that we can close it because we are at the end of our time. Thank you.
Thank you.
Thanks a lot.